For A, part A, is 0, 0 a solution for either one? And we're going to prove this algebraically. Okay, so is 0, 0 a solution for either one? So we're going to take our original inequality, and we're going to start with 0 being greater than -2 times 0 plus 3. 0 is greater than 0 plus 3. So 0 times -2 is 0, plus 3 is 3. Is 0 greater than 3? No. So 0, 0 should not be a solution. Okay, well that's great because it is down here, so we're going to fill that in with an empty circle just for our own purposes right now. I might erase that later. Over here, let's see if it's a solution. We got 0 equals -2 times 0 plus 3. Again, -2 times 0, 0 plus 3. 0 does not equal 3, so no, it should not be a solution. And over here we can tell that it is not in fact a solution because it does not actually fall on that line itself. The reason why we're doing this is we're seeing, are we supposed to be, like for this greater than symbol, what side of the line is going to be our possible solutions for this inequality? If it's y is greater than, does that mean that all the numbers over here on this side, on the right side, are going to be possible solutions? Or does it mean that all the numbers over here on this side are going to be possible solutions? 0, 0 is always a great test point for this, to see which side of the inequality we should be coloring in. Obviously, if 0, 0 didn't work on the left side of this line, that probably means that some number over here on the right-hand side should work. So let's try one. Let's try maybe the number, let's try something on either the x or the y axis. It's always really nice to have a 0 as part of it somewhere. So let's try 1, 2, 3, 4. Let's try 4, 0 over here on the x-axis. And I'm going to have to go to a new page. Is 4, 0, this is part B, is 4, 0 a possible solution? Well, let's test it out and see. We have again that original inequality. There we go. We have that original inequality of y is greater than. So again, I'm going to quickly label my x and my y so I make sure to plug them into the right spot. So I'm going to plug in y, the 0 for the y. 0 is greater than -2 times x. So instead of x, I'm going to plug in a 4 plus 3. I have -2 times 4, which is -8, plus 3 is -5. 0 is greater than -5. Well, that's a true statement. Let's double check that it shouldn't be a part of our equation, or our linear equation over here as well. 0 equals -2 times 4 plus 3. 0 equals -2 times 4, -8, plus 3 is -5 still. Well, that still doesn't work over there. But that's okay, it shouldn't. For an equation, it should not work because it's not located on the line itself. But over here, it does work because of our inequality. Now let's just try one more just for good measure to make sure we're on the right side of this linear inequality. And let's do something maybe up on the, well, okay, let's just do something in the middle. I don't know. Most of you would probably choose this number anyway. Let's do 3, 3. Okay, so something right about here. Okay, and I probably shouldn't have colored it in quite yet. But I'll tell you, I'll give you a little hint. It's going to work. All right, so part C is 3, 3, a solution. Let's test it out. All right, and it's always nice to also choose numbers that are the same because then it doesn't matter where you plug it in because you can accidentally flip-flop it and it'll get you the same thing. It's kind of a little math hack. Okay, so you have 3, greater than negative 2 times 3, and then plus 3 on the outside. So we've got negative 2 times 3, which is negative 6, plus 3 is negative 3 on the right-hand side. Is 3 greater than negative 3? Yes, it is. And so therefore, this should be a solution. So what does this mean for our graph? This means that we have all of these numbers, all these coordinates that are on this side. If I plugged in any of these numbers, any of these coordinates, they would all work. I could plug in fractions, I could just make a little smiley face, something like that. But all of these numbers over here on the right-hand side of this inequality are going to work. So what we do to represent this is we don't draw all these dots, just so you know. What we do is we sketch it, we color it in, we shade it in. On the side of the inequality that has all the possible solutions. Okay. All of these dots, again, the reason I drew those dots is so that you would remember everything that we color in is a solution. All the numbers over here, all the coordinates, are possible solutions. Now, just like we saw earlier, anything that's not over on that side of the inequality is not a part of the solution. If I plug in 0, 0, it didn't work. It's not a part of the solution set. And that's how we do linear inequalities. You'll be receiving this worksheet for the kind of a step-by-step instructions as like a refresher or reminder for your math notes of how we do linear inequalities. And you can see that this is the same exact equation. Y is greater than negative 2x plus 3 has all the step-by-step instructions for you. Just remember that any number over here that works out to be in the shaded area is a possible solution for